Alrighty, so today we're looking at linear and angular speed. It's going on page 98 when we are done. What is another word for speed? Velocity. Yes. Velocity. Right, yeah. All right, so one of the things that we need in order to get through one of these formulas here is arc length, which we've already done. We did that in December. So if you will turn in your ISNs to page 86. Turn to page 86. And tell me, first of all, what letter do we use to represent arc length? S. It's a lowercase s. And then the formula for arc length is S equals what? R theta, right? R theta. And theta is an angle, and it has to be in what? Radians. Okay, so this doesn't work if you have 52 degrees unless you convert it to radians. So the radius times the angle in radians, that is your arc length. Okay, so let's talk about circular motion here. It says arc length can be used to analyze circular motion. Suppose an object moves along a circular path S, that's your arc length. So here's your circular path that this point is moving with the radius R. So it says the rate at which the object moves along the path is called linear speed. The rate at which the central angle changes along the path is called angular speed. So there's linear speed and angular speed, or linear velocity and angular velocity. Okay? You can look at and this is how they differ. So if I start here and I go all the way around the circle, how many radians did I rotate through? Close. Radians. All the way around the circle. 2 pi. Okay? So I went 2 pi radians, right? But the distance I went depends on whatever the radius of the circle is, right? And we don't necessarily know what that is. So we could go here, and I could go all the way around the circle, 2 pi radians. If I came in some, and I went around in a circular motion and ended up here, I still went 2 pi radians, right? But wasn't my distance a whole lot shorter because the circle's smaller? So they have the same angular speed, but a different linear speed because of the distance, right? It's like when you go and you run around a track, you know, even though people start at all different spots, everybody hugs the inside once they start going, right? Because that's the shortest path around there. So here is another little example. These two circles are pretty much the same. It's just the little one's superimposed on the big one here. So we have a solid circle and an empty circle if you just look at this one. And so their radius, obviously different, right? But when I animate this, these points, they have the same angular speed because it's taking them the same amount of time to make one full rotation, right? But which one is traveling faster? The bigger one. This one has to travel faster because it has farther to go in the same amount of time. Does that make sense to you? So the outside one has a faster, the linear speed is greater, but the angular speed is the same on the two. Does that make sense to you? Kind of like going around on a turntable in a record player. Okay. So one of the linear speed formulas, I'm actually going to end up giving you two, but one of them looks like this. Velocity equals S over T, where S equals the arc length and T equals time. And then the angular speed, well, it says linear speed V for velocity, that makes sense, right? But then angular speed, this little W, it's not a W. It's like a fatter, curvier W, even though it's still not a W. It is the Greek letter omega. Okay? So it's an omega formula is what it is. So your angular speed is omega equals theta over T, where theta obviously is an angle. It is the central angle. And T is time. Okay. Everybody okay with that? We good? All right. Michael, later. Do not be doing that right now. Put them both away. Okay? So, this says, use for questions 1 and 2. A bicycle tire with a radius of 14 inches rotates at a rate of 125 revolutions per minute. Okay? So in order to do this, we talk about things in revolutions, and that's where our theta is going to come from. So one time around, one revolution around the circle is going to be how many radians? 2 pi. So if I make 2 revolutions, what's the angle? 4 pi, right? So basically, theta is going to be equal to 2 pi times the number of revolutions. Okay? If you continue to do that, I'm going to give you a 0 on it. Put it away. All right, so then it says find the linear speed of the tire in inches per minute. All right, so my linear velocity, we're using S over T right now. S is equal to R theta. What is the radius? 14 inches. So this is 14 times, then theta, the way I get theta is 2 pi times the number of revolutions, and this says 125 revolutions per minute. So 125. So what's 2 times 125? 250. So this is 14 times 250 pi. So let's think smarter, not harder here, right? I don't want to do 14 times 25. It's not that big of a deal. But if I think of 14 as 7 times 2, what's 2 times 250? 500. And then 7 times 500 gives me what? 3,500. See how it's easier to break it apart like that? And this is an arc length, and this was in inches. So then I want my velocity. Velocity is arc length, which is 3,500 pi inches over time. And the way you determine what time you get to substitute in, it's not based on what the question is asking you for. It is based on what is tied to the revolutions. This says revolutions per minute, so that's for every 1 minute, because that's how I came up with those numbers. Once you've set it up, and you've canceled anything out that you can, there's nothing to cancel out, then you look to see what the question was asking for. It was asking for inches per minute. I have inches per minute. So this is 3,500 pi inches per minute. And that's my answer. Okay, everybody good so far? So now I'm going to find the angular speed. So omega equals theta over t. So remember, theta is equal to 2 pi times the number of revolutions, which is 125. So theta is 250 pi. It looks like a W. It's not a W. It's a fat, puffy W. You'd know that if you were paying attention to me in that part of your accent. Exactly. All right, so omega then is equal to theta, which is 250 pi, and that's radians, over time, which again, I get from here, that's 1 minute. And then it's asking me for radians per minute, so that's good. I don't have to convert anything. My final answer is 250 pi radians per minute. Okay. Everybody good so far? So there's a different velocity formula that I'm going to show you. I'm going to show you where it comes from. This is the one that we're really going to focus on, or the one that we're really going to use. Like, there's nothing wrong with using this one because it's not wrong, but we're going to use the other one pretty much exclusively because those of you in AP Physics, this is hitting you next week, like Monday, Tuesday, Wednesday, somewhere around there. So this should start to look familiar. So I want to use the same thing that you're using there. So your velocity, the velocity formula I gave up there, it's S over T, right? S is arc length. What's the formula for arc length? R theta. So in the numerator, instead of S, I can put R theta. Put that over T. Y'all agree with that? Then I'm just going to rewrite that exact same thing a different way. This is the same thing as this. Do you agree with that? And what does theta over T equal? The angular speed is omega. So this really can be R omega. So the velocity, a different velocity formula, again, you're using the same pieces, you're just kind of doing it a little bit differently. R omega, this is the one we're really going to use because you need to be able to convert easily back and forth from angular to linear velocity, and this is the easier way to do it, basically. Okay, so you just kind of do whichever one makes the most sense at the time, and this is the one that would make the most sense for most of y'all. Okay, we good? All right, so let's look at number 3. It says, a 16-inch diameter tire on on a car is making 500 revolutions per minute. Find the linear speed of the tire in miles per hour. So it's asking me for linear speed, but I have to find angular speed first because we're going to use r omega. So omega is equal to theta over t, right? So theta is 2 pi times the number of revolutions, that's 500. So that'll be radians in the numerator over time. And again, this says revolutions per minute. So this is for every 1 minute. So this ends up giving me 1,000 pi radians per minute. Not my final answer because nobody asked me for angular velocity. They asked me for linear. So now I'm going to use that. Linear velocity is equal to r omega. What's the radius? 8. So I'm going to do 8 inches over 1. If it's not a fraction, we make it into a fraction. We're going to multiply that by 1,000 pi radians per minute in fraction form, meaning this will be 1,000 pi radians for every 1 minute. If you are not neat and concise about this stuff, you are going to get lost in your own work. If you can't read your own handwriting and keep up with your own work, this is going to be nearly impossible for you. Just putting that out there. All right, so when I multiply these together, okay, we need to talk about units just a little bit, is when I multiply these together, this is going to give me the velocity in inches per minute. Okay, and you have to think about what's happening with your units here. I have radians up here. I don't get inches radians per minute. It doesn't work that way for radians. Radians and degrees are something that we call a unitless value. It doesn't actually have a unit on it. If you think about how you find a radian, it's arc length over circumference, right? And so basically that's inches over inches. So those inches cancel out and you don't have anything. All you have is a ratio. And a radian is a ratio of arc length to circumference. Does that make sense to you? So it's just a ratio, but we put radians on it because it implies a rotation. Kind of same thing with degrees. It's what we consider a unitless value. We put units on it, obviously, to say radians per minute. Otherwise, we have like nothing to call it. But when you're converting things and units are canceling out, anytime you substitute it in, it just kind of gets absorbed in the problem. The big three, time, distance, and mass, those are the ones where the units on there, they say it. If you multiply them together, they get multiplied together. And if they divide out, that kind of thing. But the radians just kind of go away, all right? So that means here, I'm just going to mark it out so I don't get myself confused. It's just gone. And then this gives me 8,000 pi inches for every 1 minute. But the question doesn't ask me for inches per minute. It asks me for miles per hour. So I have to convert. And every time I do this, I don't care what grade level I teach this at, there's always somebody, sometimes too many people, that were never truly taught how to easily convert and keep up with all of your stuff. Okay? So this is the best way to do it. Are there other ways? Yeah, but to me, this is the best way. This is the way I do it, because otherwise I'm going to lose myself and stuff. I have inches per minute. I want miles per hour. So I'm going to start with my inches. I'm going to multiply by something that has to do with, that can convert my inches. Inches have to go in the denominator so that they can cancel out. I can easily convert inches to feet. So I know that there are 12 inches for every 1 foot. Okay? But I don't want feet. I want miles, right? So I'm going to multiply again. Feet has to go in the denominator so it can cancel out. And miles can go in the top. Oops. How many feet are in a mile? 5,280. That is a life skill. You absolutely have to know that number. That's not going to be on any kind of chart you get. You have to know that. Okay, so 5,280. No, it's not 0.1. That's ignore that. I don't know. Okay, whatever. It's not 0.1. Just ignore that. And so now you're good so far? And I circled miles because I got my miles. I need my hours. I have minutes. So now, you can look back at this minute. Since it's down here, minutes has to go on the top so that it cancels out. And I know that there are 60 minutes in 1 hour. I want hours, so I'm good. Okay, so now I have it all set up. Okay, I have converted. I just need to fix my numbers now. So now I go through and do this in hopefully a semi-logical fashion, right? 12 divides into 60 evenly, right? How many times does 12 go into 60? 5. So this is 1, this is 5. That's nice. This 5,280, I can divide those both by 10 to knock out zeros. Well, you can, but I totally would not do that because then that's going to make your reducing a whole lot harder. You do not have a calculator. No. So these two are both even. I would just divide them both by 2. So this is 400. What's half of 528? 264. Okay. So 264, and then I can take half again. That makes this 200. That makes this 132. I can take half again. What's half of 132? 66. Yeah. Then I can take half again. That's 33. That makes this 50. Right? And then 33 is just divisible by 3 and 11. The only thing I have left in the numerator is this 5, the pi. Don't forget your pi. I'm sorry, that 50 and the 5. In the denominator, all I have is the 33. So is anything else going to reduce out? No. So my velocity then in the end, 5 times 50 is 250 pi, don't forget the pi, over 33, and that was miles per hour. And you doing mph is totally fine. Do it that way or put mph for miles per hour, doesn't matter either way. So the setup should be pretty easily. What's going to kill most of you, or some of you anyway, is just the arithmetic getting through that basic math. That's a skill you have to have. Okay? Huh? It's dimensional analysis, that's all it is. Well, the dimensional analysis part, that's going to be easy for most of y'all too. It's the actual canceling out and keeping up with your numbers. That's the part that concerns me the most, honestly. All right. So yes, but not everybody always seems to understand dimensional analysis. So if you got that down, this is really a piece of cake. All right, so number 4, a circular saw blade with a diameter of 9 inches rotates at 2,800 revolutions per minute. Find the angular speed of the blade in radians per second. So they're not even asking me for linear here, just angular. So I can just find angular and stop. So omega is equal to theta over t. Theta is 2 pi times the number of revolutions, which is 2,800. All right, so that's going to give me radians in the numerator, over, I get the time, revolutions per minute. That means this is for every 1 minute. So what's 2 times 2,800? 56. So it's 5,600 pi radians for every 1 minute. And then this asks me for radians per second. So I'm good with my radians. I just got to convert my minutes. So where does the 60 go? The bottom. Because this has to be minutes. Boom. 1 minute, 60 seconds. So now I have radians per second. I can divide them both by 10 to knock out zeros. Then is 56 divisible by 3? No, so then it's not evenly divisible by 6, which means all I can do is divide it in half. So this becomes a 3, and when I divide this by 2, you get what? 280. So that means that omega is equal to 280 pi over 3 radians per second. What questions do you have? We good? All right, let's look at 5. Windmill has blades that are 14 feet long. If the windmill is rotating at 5 revolutions per second, find the linear speed of the tips of the blade in miles per hour. So I want linear speed. I have to find angular speed first. So that's going to be theta over t. Theta is 2 pi times what? Revolutions, which is 5. It gives me radians over 1 what? Second, because it comes from here. So that means I get 10 pi radians per second. Okay? Then I go and find my linear speed. That's r omega. So what's the radius? It's going to be 14 for the blades. Yeah, so this is going to be 14 feet over 1 times 10 pi radians over 1 second. Okay. So then, remember that the radians just cancel out there. And so this is going to equal 140 pi, oh my gosh, pi, feet for every 1 second. Do I want this in feet per second? No, I do not. I want it in miles per hour. So I'm going to change my feet to miles. Feet goes in the denominator, miles go in the numerator. How many feet a mile? 5,280. Feet cancel out. I'm good. I got miles. Seconds, I can go to minutes first. So seconds go in the numerator, minutes in the denominator. 60 seconds for 1 minute. So my seconds cancel out. Then minutes to hours. The minutes cancel out. 60 minutes, 1 hour. So now I've got my miles per hour. I'm good, right? The rest is just arithmetic. Okay, so I've got 5,280. I can divide that by 10 to knock out a 0. Out of any one of the 3, it doesn't matter, so I'll just do it with, I usually just start at the front if it doesn't really matter, but that doesn't matter either. Then 528, half of that is what? 264, right? 5,280 is going to come up a lot. You're going to have to divide it in half a lot, so you'll kind of just learn these numbers, hopefully. Divide that in half, that makes this 7. All right, so does 7 divide into 264? I don't even care. It takes too many brain cells, all right? I'm not even going to try. I know it's even. I can move on to the next one, right? Does that make sense? Like there's no use in, maybe it does. We'll figure that out at the end. I divide this in half, I get 132. So that makes this 30. I can divide it in half again, but I think that I don't want to get 15. Like you have options here, right? You can, there's nothing wrong with it, but I think I'd rather multiply a 30 than a 15 just because it's easier. So instead, I want to take half of this one. So this will give me 66. This gives me 30. Okay, well, the 66 and the 30, they're both divisible by what? 6. 3 and 6. So I'm just going to go ahead and go with 6. So this gives me 11. This gives me 5. So in the numerator, I'm left with 7, 5, and 30 in the pi. In the denominator, all I have left is 11. And 11 doesn't divide into any of those. So whether you multiply 7 times 5 to get 35, then multiply that by 30, or 7 times, like it doesn't matter what order you multiply in. Do whatever you think makes the most sense to you, and tell me what we get in the end. Give everybody a second to think about it. I know that it's going to be miles per hour. All right, so what's the numerator? 1050 pi over 11. Okay, we good? What questions do we have? Okay, I'm going to start number 6 just a little bit differently with the conversion stuff, just because I want you to see you kind of have some options here. It just kind of depends on what pops up at you. So we're going to start the same way by finding the angular velocity, because it says, gives me all this information. It says find the linear speed. So I have to find angular speed first. So omega equals theta over t. Theta is 2 pi times what number here? 40, okay? And since it's RPM, that means revolutions per minute, right? So this is going to be radians over 1 minute. So then this gives me 80 pi radians per minute. So then I move on to this. This is r omega. What's the radius? 25. So this is 25 inches over 1 times 80 pi radians for every 1 minute. Okay, so on the other ones, at this point, I actually multiplied them. We got an answer, and then we converted. You don't have to multiply first. I mean, the one above it, we multiplied 14 times 10, so it was like no big deal, right? So here, I'm not saying 25 times 80 is really that big of a deal, but you don't have to multiply them. We're about to try and take all this stuff back apart anyway, right? So we can just start converting right here. There's nothing wrong with just converting right here. So that's what I'm going to do. I'm going to start multiplying. So I'm just going to cancel out the radians so I don't confuse myself, because they're just going to go away. And so the inches, let's see, what do I want? I want feet per second. So the inches goes in the denominator. 12 inches, 1 foot. Those cancel out. And I got feet, so I'm good. Minutes. Minutes goes in the numerator. Seconds in the denominator. I want the seconds, so this is 60 seconds, 1 minute. Okay, everybody good with that? So now I got it, and so now I'm going to reduce. So go ahead and reduce however you would. And then I'll talk you through one way to look at it anyway. There's not really like a right, I mean, there's obviously some wrong ways, but there's not necessarily a right way, there's different ways. What I always do first to help reduce my numbers is if I can divide tens out, I do that, because that seriously reduces things quickly, right? So then I have 12 and 6 left in the denominator. 25 isn't going to divide out with either one of those. But 8 is divisible by 4, so this becomes 2, and this becomes 3. Then that 2 can divide with the 6, and I get a 3 there. So in the end, then I get velocity is 25 pi over 9 feet per second. Okay, what questions do you have? What? Say that one. Does it matter? It absolutely matters. Oh, I see what you're saying. Yeah, okay. I misunderstood your question at first. So you're saying, can you leave your answer like this? No. It's not necessarily, I mean, they mean kind of the same thing, but that has the rate kind of as a separate thing. The units should always kind of be separate. Like we leave it in there to get us through everything, and this is basically what it means and how I would set it back up if I had to. But then that's 25 pi over 9, and it's feet per second. Does that make sense? That's like the proper way to do it. Good. Any other questions? All right. Y'all do number 7. And then I will come and check you. Once you have it correct, then I will give you your assignment. Okay, here is my work if you need to see it. And there's, again, different ways to process through everything, but that's... And I know from the work, you can't necessarily tell what I did first or what not, but there you go. Okay? If you reduce everything as much as you can before you multiply, you can't reduce after you multiply, so you don't even have to try with the bigger numbers. Okay?